Okay. So there's four names that mean the exact same thing. One of them is called solutions. Now, I think you're the only class that's actually been introduced to this a little bit. Do you remember a couple of the other names? Yeah? Zeros, good. X-intercepts, Harlan's all over this. And I don't know if I told you the last one. And roots. Those are all synonymous. They mean the same thing on the graph. Solutions, zeros, x-intercepts, and roots. So, they kind of throw you off on questions on your SAGE test and your book. They mix them up. Sometimes it asks for what are the roots. Sometimes it asks for what are the x-intercepts. Sometimes it asks for what are the zeros, or what are the solutions. All of those do the exact same thing. They all mean the same thing. So, we're going to solve the following quadratic and find the solutions, zeros, x-intercepts, and roots. X squared minus 16 equals 0. I said solve. What would you think to do when you saw an equation like this? Chris? Just a 0? So, both sides. That's the key phrase. And what you were trying to do is find the value of x, right? We're trying to isolate x. Okay? Christine, now what would you do to solve for x? Square root. So Christine, what is the square root of 16? 4 is half of it. There are two answers, plus and minus 4. When you take the square root, it gives you two answers, plus and minus 4. So plus and minus 4 are the solutions to the equation. A solution means it makes the equation true. If we plugged in 4 for this x, whether it's positive 4 or negative 4, plus and minus 4 squared is 16. Minus 16 equals 0. So that was true. 0 equals 0 is true. Okay? Being a 0 means these are actually points on the graph. X is 4 and x is negative 4. Its height, their heights are 0. That's why we call them zeros. Their heights are 0. Well, if their heights are 0, where are they on the graph? They're where? The x-axis, so they're actually x-intercepts. That's why we have all these names for the same thing. 1, 2, 3, negative 4. 1, 2, 3, positive 4. Put arrows and label. So when we found x equals positive 4 and negative 4, they're on the x-axis, so they're x-intercepts, and they're called zeros because they have a height of 0, and they're also called roots. So when we take the square root, we found the roots, it was plus and minus 4. Okay, this is an x squared, which means it's a quadratic. So what do quadratic graphs look like? I use parabolas. There is a very important point on the parabola that we need to graph. The vertex. And then we use symmetry. Well, there's a few different ways we've learned to get the vertex. I'm going to set this equal to y. That 0 is just y. Okay? And do you remember, maybe I'll put it up here. Y equals a times x minus h squared plus k. Or ah's and k's. what does the H do to the graph? Horizontal shift. HS. And what does, maybe I'll put that different color, that's not really showing up. HS. And what does the K do to the graph? Vertical shift. And we have a saying. Opposite, same. Ah. So this minus 16, is that the horizontal shift or the vertical shift? Is it in parentheses with the x, or is it after the x? It's after, so that's a vertical shift. In 4 words, would you turn to your neighbor and tell your neighbor what the vertical shift is? Make sure you turn left and turn right. Turn the other direction and tell them again. 4 words. Okay, Yen? All right, everyone. Yen, what are the 4 words for a shift? Good. Vertical shift. This one goes down. We have a vertical shift down 16. So that's where our vertex is, because we can go, this opposite same creates our vertex. So our vertex, x, has no numbers by it. So that's because the horizontal shift is 0. And then the vertical shift was negative 16. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. There's negative 15, so here's negative 16. There's our vertex, and remember when you graph through it, you need to carefully make sure it is curved at the bottom. It should not be a V. Those graphs are coming up in a little bit. V is a different type of graph. It should be a U, parabola. So, what we're doing today, you should be doing 2 things. Finding the solution, which is this, x equals plus or minus 4, and I want you graphing it. Every problem I want you graphing. So you realize these answers you're getting relate to the graph. Can someone explain in their own words how these answers we got here relate to the graph? You want to explain in their own words? How does x equals plus or minus 4 relate to the graph? Connor? The x-intercepts of the parabola when it crosses the x-axis. Okay? So let's try another one. Example 2. M squared minus 36 equals 0. Would you please find the roots of that? Go through and find the roots of it. When you think you have them, turn with your neighbor and see if you're getting the same. Find the roots. If I say the word root, solution, x-intercept, or 0, it all means do the exact same process. It means solve it. Okay, Landon, what'd you get? So m equals plus or minus 6, yep. Because we add 36 both sides, and we get m squared equals 36, how do we undo a square? Square root. But make sure if you are applying the square root yourself, there are 2 answers, positive and negative 6. When we get these 2 answers, or these 2 roots, who can explain in their own words what this represents? We get these, what does it mean? Waji? The x-intercepts of the parabola. It crosses twice, at positive 6 and negative 6. So we can start to build our graph. First of all, I would look at the m. Is m positive or negative? Positive. So our parabola is opening up if it's positive. Can anyone tell me where our vertex should be? 0, negative 36. Opposite, same. We have m squared minus 36 equals 0. Opposite, well, inside here, that number is 0. Same, this number, vertical shift, which means it goes down to negative 36. That's our vertex. So let's build the graph. We need to go 1, 2, 3, 4, 5, negative 6. We have an x-intercept at negative 6. An x-intercept at positive 6. Now, do I want to draw 36 little lines down the y-axis? No. You can. I like that idea. Harlan, what did you say? Go by sixes. We could totally do that. Negative 6. 1, 2, 3, 4, 5, 6. Isn't 6 times 6 36? So if I count by sixes, and you have to mark that you're counting by sixes. I showed the first line was negative 6, and I showed where I wanted was negative 36. And graph your parabola. That's not a very good parabola. Let's try this again. Your lowest point, your minimum should be on that vertex. Okay? Any questions? You ready for a challenge? Okay. Challenge accepted. Negative 3x squared plus 15 equals 0. Please find the x-intercepts. Last time I said please find the roots. Is that any different than finding the x-intercepts? Nope, it's the same process. Make sure you have a squared on that x. That's why you take the square root, is to get rid of the square. Okay, you should put squiggles. Squiggly equal sign because it's not an exact value, right? It's a rounded, approximated value. Good. Does this one come out nicely? No. But we can approximate the decimal to where we would graph it. For your answer for the x-intercepts, you should put the exact value. The exact value would be in square root form. So in minus 15, minus 3x squared equals negative 15. Before I do the next step, Jade, what's the answer that you got at the end? Oh, x equals plus or minus 5i? I think you're really warm. Was it a negative 5 that you were taking the square root of? So it's plus or minus just square root 5, I believe. Because when we divide by a negative, that is coming up, Jade, though. So we'll be prepared for that in a minute. We get a positive 5. So we apply the square root, which gives us plus and minus root 5. This is the exact value. If it was asking for the x-intercepts, I would not round the decimal unless the directions specifically say round the decimal. If it doesn't say round the decimal, you leave it in exact form, which is plus and minus root 5. For the purposes of graphing, you'll want to know the decimal. For graphing, we would type in square root 5 and get a decimal. What's the decimal approximately root 5? Yeah, approximately plus or minus, oops, no root, 2.24. So about 2 1/4. Why do I put squiggly equal signs? Because I'm approximating. It's not that I'm unsure, it's I'm rounding. So it's approximately. Okay, now we have 2 points. We need a vertex. How can we find a vertex? Okay.
There, the equation.
It is right there in the equation, Bryson. Okay, I need two numbers. The vertex would be... Ooh.
0.
Yeah, inside with the x, there's just a plus 0, which is why it's not written. So it's 0, comma, 15. So that's a positive, because our quadratic is negative. What happens when the quadratic's negative? Flips upside down, it'll be opening downwards. Just one sec. So we need to get a height all the way up to 15, which is this time going to look like an upside down T. So we need to go all the way up to 15, which I can go 5, 10, 15, counting by 5s. And then 1, 2, 3, negative 3. 1, 2, 3, positive 3. Where would we find plus and minus root 5, which is approximately 2.24? In between what? In between the 2 and the 3. But closer to the 2, right? Closer to the negative 2. And we have at 15, now you can draw your parabola. Connor?
Is the 0 multiplying the x or adding or subtracting? Because if it was multiplying, would it take away the x?
Are you talking about this 0?
No, the 0 first.
It's being added. It's being added. Yep. He is a deep thinker. Okay? If you've survived that challenge, I think you're ready for the next challenge. Example 4. Two x squared plus 8 equals 0. 2x squared plus 8 equals 0. Please find all zeros. What do I mean by find all zeros? Find the x-intercepts, because the x-intercepts have a height of 0, right? If you're on the x-axis, you have a height of 0. So when I say find all zeros, it's saying find all points that have a height of 0.
That's definitely the answers for root 1, right?
Not on this one, because it comes out nicely. You're really close. You forgot one little detail on the 2. What number times itself is negative 4? Can 2 times 2 be negative 4?
Oh no.
Can negative 2 times negative 2 be negative 4? So is there a way to have a real number times itself be negative 4?
Oh, I just said the I.
Ah, there you go. You got it. Okay, Brian, what'd you get? Okay, so Robert's over here. X equals plus or minus 2i. Thumbs up, thumbs down. You agree? Disagree? Okay, someone else? Explain to me where this I came from. Brian? This Brian?
Because when you have negative 4, you can't like equal square root that.
You can't take the square root of negative 4, right? In the real numbers, it becomes an imaginary number. So you also have minus 8. So you have 2x squared equals negative 8 divided by 2. We have x squared equals negative 4. The square root of negative 4 is plus and minus 2i. I. So the question is actually, what are the x-intercepts? Where is 2 plus and minus 2y on the x-axis? Say louder. They're not there. So our answer, actually, I probably shouldn't box that up, because our answer is there's no solution in the real numbers at least. And you'll see why on the graph. Okay, who can tell me the vertex just by looking at the equation? 0, comma 8. That plus 8 is our vertical shift, 0, comma 8. Okay, so our vertex, 0, comma 8. Let's start building the graph. And we claim there are no x-intercepts. So if this is 0, 8, 1, 2, 3, 4, counting by 2s, 2, 4, 6, 8, and there are no x-intercepts, how could a parabola be shaped so it never crosses the x-axis? It goes up, because this is a positive 2. So we can't just graph a vertex only. We need to find a couple more points. Does anyone have questions how it never crosses the x-axis? It's a positive 2, so it has to be going up to the positive numbers. So if it's already at 8, it's never going to go down any lower. It's always going to go up, so it will never cross the x-axis. How can we find some more points? Put it in your calculator, okay. How can we use our brain to find more points? Plug things into the equation. Because our equation is 2x squared plus 8 equals y. We were using 0 before because we wanted to know whether y was 0, but now we want to know any y. So we need to do a little table of values. Our vertex, 0, 8, should always be in the middle. And we need to do a couple smaller than 0 and a couple bigger than 0. Andres, can you give me a couple x values that are smaller than 0? Sure, that's nice to work with. Negative 2, is there one between them we could also use? Negative 1. Then we could do positive 1 and positive 2, right? They will be the same, so we really only have to figure out 2 of them, and then we use symmetry. Okay, so over here we can do our work. Don't like that color today. Okay, we take 2. Wherever there was an x, we replace x with our new x value plus 8. So 2 times negative 2 squared plus 8. Please excuse my dear Aunt Sally, we can do this without a calculator. Let's use our brains. You do parentheses first and exponents. Negative 2 squared is 4. 2 times 4 plus 8. Now we multiply, right? Connor P, what do we get when we multiply? What has to be multiplied? 2 times 4, yep. So that would be 8. So we have 8 plus 8, which is 16. Okay? Now we're putting the next number, negative 1. Do the exponents, then multiply, then add. Put fingers up in the air, what number do you get? Do the exponents, then multiply, then add. Fingers in the air, what number do you get? Brian, Macias, that whole row of girls, are you holding up answers? Okay, you can put your hands down. But Hunter, I'm going to have you correct that. Are you done? Yeah? Pen for you. Okay. can put your pencil on the ground. There's the key. All right, Kayla, did you figure it out? When we plug in -1, what's the y value? What? Do you know why? We do -1 squared first, which is -1 times -1 becomes... Kayla, what? So we have 2 times 1, which is what, Kayla? 2 plus 8 is 10. That's where we get the 10. Okay, these boys already said we can use what to get the other 2? Same thing, symmetry. Okay, so we have 1 and -2. Make sure you mark it on your graph. 1 and +2. You should put arrows. You should label your graph always. Looks like we need to take this up to 16, 12. I'm counting by 2s. That's 10, 12, 14, 16. So negative and positive 1 has a height of 10. Positive and -2 has a height of 16. Okay? So if it never crosses the x-axis, there are no roots or solutions or zeros or x-intercepts in the real numbers. If you come across an imaginary solution, that should be your hint that's never going to cross the x-axis. What's another type of graph that's also a parabola that would never cross the x-axis? What do you mean by one of those lines? Still needs to be a parabola. I'm still talking about parabolas. What's another type of parabola that would never cross the x-axis? Okay. Well, we're not going to do sideways because it's no longer a function. There we go. Down, and where does the vertex have to be? It has to be down here somewhere, and then it curves down. Parabolas can also touch once. They would touch once if the vertex is on the x-axis. Okay? So if you only get one solution, it's called a repeated root because it touches once on the x-axis.
How is that?
Because there can be as many roots as the power, including repeated roots. So if it's x squared, Davis, put that away, please. Okay, so, I just lost my note paper. I think we're going to, exactly, yeah, take a stretch break really quick. We have a few more properties to do. Stand up, go across the room, find someone you don't normally talk to on your row, and tell them your favorite part of Thanksgiving dinner. Stand up. Okay, your favorite part of eating. Stand up and go across the room. Yeah, I don't want minus. I want you to add how many you got. And if it's more than 18, then you got extra credit. If it's less than 18, then it just helps you. Stand up. Stand up, stand up. You should be mingling with someone not on your row. Don't introduce yourself. Thank you. If you put yours in your folder, figure out your percentage too if you didn't do that. Just divide and move the decimal twice. Okay, start making your way back to your seat, please. Start making your way back to your assigned seat, please. Harlan, lift up your right heel. She's trying to get that folder. All right. Okay, now we're going to move on to another type of solving. Solve using the zero property. This is a really useful property.
Is this like a new section?
Nope, continue the same notes. Same notes. There are lots of ways to solve quadratics. I'm trying to show you all of them, so when you do your homework, you've seen all of them. Of course, you didn't have homework last time. Well, yeah, but it's because the equation looks different. Okay, so solve by using the zero property. Example 5. The equation is x plus 1 times x minus 1 equals 0. What? What?
X minus 1 divided by 5.
Oh, minus 5. Yeah, that's what's supposed to be. Sorry. My mouth didn't say the right thing. Okay. This looks different than the other equations. Can anyone see the vertical shift right away? No. Nope. But the nice part about these is you can see the zeros right away. If it's already factored, aren't these how we wrote our answers for the factoring test? We got 2 binomials. These are called factors. X plus 1 is a factor. X minus 5 is a factor. To get the solutions, roots, zeros, or x-intercepts, you set the factors equal to 0. And I'm going to start writing something that I'm going to erase, so you don't need to write this. If I want to solve for x, please put your eyes up here. Eyes up here, please. I could divide by x minus 5. Is that legal? Because this is being times. It's legal to divide. Okay, don't write this because I'm going to erase it all. Which means I divide by x minus 5 on both sides. So I have x plus 1 on the left equals, what would I get on the right? 0. 0 divided by x minus 5 is 0. So it just takes the first binomial, sets it equal to 0. Now I'm erasing, so that's why you shouldn't be writing this. I could choose to divide by the first one instead. And look what happens. This is why this property is legal. X minus 5 equals 0. Okay, I'm going to erase this. Because this is what I do. Because I know this property works, I don't have to show those steps. I just do a little squiggly, and I say x plus 1 equals 0, x minus 5 equals 0. So therefore, x would be what number here? Negative 1, and this one? Positive 5. There are my roots, my solutions, my x-intercepts, my zeros. What? I'm not erasing this part. Thank you. You may write this. Please do write this. You can take the binomial, set it equal to 0. Okay, sorry, I won't skip the step. I'll show you the intermediate step. X plus 1 equals 0. I subtract 1 both sides. I add 5 both sides to get x equals 5. So, those are your 2 x-intercepts. Now, to graph, we need a vertex. How do we find a vertex?
Is it the horizontal vertex on this?
Okay, This is why I teach you. That's exactly right. Okay, we're going to distribute. Shh, guys. I already gave you your talk break. You need to stop talking now, though. And I get x squared minus 5x, and I distribute the 1, plus 1x minus 5 equals 0. So my standard form would be this. Standard form, remember, is decreasing in power. X squared minus 4x minus 5. We've learned how to find the vertex when in standard form. Does anyone remember? Sit. You're in the right realm. You have your variable switched around. We find the axis of symmetry. X equals negative b over 2a. X equals negative b over 2a. When it is in standard form, you should know your b's and your a's. Okay? Fingers in the air, what is the b from that standard form? Fingers in the air, what is the b? B should be negative 4. It goes A, B, C. So when we plug it in, it becomes a negative 4. Divided by 2A. Fingers in the air, what is A? Okay, Andres, what is A? It's a number. What is A? How many x squared is the coefficient? 1. So divided by 2 times 1. So we get 4 over 2, which is 2. That's the x-coordinate of the vertex. But we need a y in order to be a full point. Hunter Blunt, if I know x is 2, how would I know the y? 2 into x. Good. And so since we're not actually looking at the zeros anymore, I can change this back to a y, because the vertex isn't on the x-axis. Okay, so we're going to plug in. X equals 2. 2 squared minus 4 times 2 minus 5 equals y. Please figure out the value for y. Andrina, if you could come correct your test, get the key. Here's a pen. Find the value of y, please. Here you go. My favorite lesson's coming up in a couple days. Oh, you will wait and see. Sure. Okay, when you have the y value, please put it up in the air. What's the y coordinate? I don't know if you have enough fingers for that, actually. Do you have enough fingers for that? Not really. Okay, you should get negative 9. Because you should be using, you can do this without calculators, guys. You should practice doing the math without a calculator, using your brain. Okay, shh. I need everyone to turn forward, please. Shh. I need to turn forward. You do exponents first, which is 4. 2 squared is 4. Then multiplication. Then you add and subtract left to right. 4 minus 8 is negative 4 minus 5. So negative 9 equals y. So our vertex was 2, negative 9. So we can draw. We have 3 points now. We have 2 x-intercepts and we have a vertex. So you can draw your parabola. Notice the vertex is in the negative side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can do 4 quadrants every time, but if you look at your points, you don't always have to do all 4 quadrants. There's -1, 1, 2, 3, 4. There's 5. You should put arrows. You should label your x and your y axes. And we have 3 points to plot. You know 2 x-intercepts, and you know a vertex. Once you have the 3 points, with the vertex being the middle one, you can graph the curve. So we have an intercept here at -1 and 5, and 2, -9. So we can graph the parabola. Okay, we're going to do one more that piggybacks off of our last test. What was our last test on? Factoring. So we're going to do example 6 has factoring. Solve by factoring. It is 2a squared minus 15a plus 18 equals 0. Solve by factoring. You guys should know how to do that. Would you factor it and get the 2 binomials? What method would you use to factor? What method do you use to factor? The X box. X box. You guys should know how to factor. We just had a test on it. First times third goes on the top. We always look to add to the middle coefficient. Well, that's an issue. We do have Operation No Fail tomorrow after school in Miss McDonald's room. My day is Tuesdays after school. We have Monday and Wednesdays before school. You can just look on that poster. It has all of the dates listed and the times and the room numbers. That's it. Do the Xbox, please. Today is Wednesday. Did you get it? Okay, put your test in your folder, please. You should be finding the 2 binomials using factoring. You need to catch up a little bit. You don't have the newest one written down. You haven't even written it down. Good. Some people are even going further because apparently you get what we're doing. Okay, the X box. What goes on the top? What do we look to multiply to, Jamie? To what? I didn't hear you. It's 2 times 18, which is 36. And we are adding to what, Jamie? Good, you have to take the negative sign. So, multiplying to 36, there's a lot of options. Which option adds to negative 15? Negative 12 and negative 3, A and A. Because a negative times a negative is a positive, and a negative plus a negative would be a negative, so that would work. Then you fill in your box. Okay. Chris Herrera, what goes in the top left of the box? Good, the first term. And the bottom right, Chris? Good. And then in the other two, you put the A's you just found. Negative 12A, negative 3A. Okay? Andres, what would you do now once the box is filled in? Great. Perfect. Greatest common factors, rows and columns. So what would you get here on the top row? 1A, yep. And here on the bottom row? Now what goes into 12 and 18?
6.
It is 6. Now, I know I have to multiply it to a positive 18, so I'm going to put negative 6, because a negative times a negative will give me the positive. Okay? What? 18 divided by negative 6 still works. It's negative 3. We do need to, because when we do this row, or this column, we get 2A, and it has to be a negative in order for 2A times negative 6 to be negative 12A. And in this row, we pull out a negative 3. Both here and here need to be negative, because a negative times a negative will make the positive 18.
So when you know how you factor, negative 6. That's what I meant. I know how to do this. I know how.
Do you agree that there's at least a 6?
Yeah.
Okay. You need your signs to work out. Well, there's two things that will happen. Either when you see both of them are negative, that's a clue that it's negative. Okay, if you see that one is negative, but this bottom right is positive, these both have to be negative every time.
So does it happen?
Guys, you can divide by a negative. Negative 18 divided by negative 6 works. Oh, positive. Well, it's negative 3. It works. You can divide by a negative 6. Factoring is dividing. You can divide by negative 6, I promise you. 18 divided by negative 6. If this is positive, are you listening? If this is positive, the only way to give a positive, you have two options. A positive times a positive, or a negative times a negative. The only way this one can be a negative is if that guy was negative. So that tells you this one has to be negative times a negative. With practice, eventually you get it.
Well, I got the right answer. It's just I just don't know how it works because I just didn't understand that.
You can pull out a negative. It's okay. Okay. My goodness. Okay, we gotta finish this problem really quick. Those are factors. These are not solutions. Okay, really quick, I saw some already beginning this process. These are factors, not solutions. To get the solutions, the zeros, the roots, the x-intercepts, we use the zero property. So I just do 2a minus 3. I set that equal to 0, and we get a fraction. We add 3. 2a equals 3 divided by 2. A equals 3 halves, which for graphing purposes is 1.5, right? Now, a minus 6 equaling 0 tells me a is positive 6. So on my graph, 1, 2, 3, 4, 5, 6, I have 1.5, maybe different color, 1.5 and 6. How do you find the vertex? That's the symmetry, negative b over 2a. Oops. Negative b over 2a, because we're almost out of time now, so I'm going to just have to tell you what the negative b over 2a, negative b becomes a positive 15 over 2 times 2, shh, guys, which is 3.75. When you plug in 3.75, you get negative 10.125. Sometimes the vertex isn't pretty, and that's okay. There's going to be a couple on your homework where the vertex isn't pretty. So negative 3, and if this is negative 10, negative 3.75 in here.
This is a reminder and an invitation
Get your planners out, if you would.
University of Utah, the gymnasium today here at lunch. Additionally, there will be free pizza for seniors who attend the guest speaker lecture. You guys will have everyone here capacity. Share the University of Utah with you guys. Have a great day.
Here is the homework. Every single problem, I want you to do 2 things. Every single problem. Find the solutions and graph. Even if the directions in the book don't say graph, I want you to graph. Every single problem, you should have the solutions and you should graph. We do have tutoring tomorrow after school in room 121, which is just down the corner that way. We have Monday mornings tutoring. Here's the poster if you need to know tutoring. Mondays and Wednesday mornings we have tutoring, and Tuesdays and Thursdays after school we have tutoring. You have a question?
So, three graphs, right?
The graphs need to be exact. 2 exact intercept points, and the vertex needs to be exact.
I don't know, I mean, like one graph like one graph.
You can do it on line paper, but you have to draw your axes. Yeah. Okay, please put the calculators in order.